Thanks, Kevin.
Thank you, Robert.
You bet.
Hey, thanks a lot, guys. You guys. I want to start off with just some items about the event itself. But first off, my team and I, Dwayne Davis, David McKenzie, we spent the better part of the last week in this store calibrating these panels to their utmost performance capabilities. We did two separate calibrations, one for day mode and one for a night mode. We're going to show you the day mode first as we talk about the procedure that we'll put you through for the evaluation of the panels. There was a lot of interest in day mode last year because some people need the capability of having a very bright picture depending upon the environment that their televisions are in. I think it's also one of the reasons why the F8500 actually won last year was because it gives you the best of both worlds. It had a great night mode, very accurate color, great black levels, but also, as Mike Wood had explained, was capable of being far brighter than any other plasma that had ever been produced before. So with that, let's throw everything in day mode. I'll spin up a Blu-ray disc and then explain to you what we're going to be doing, and we'll take it from there. I think, is MIDI in here? Did we put MIDI in here, David? Yeah, we did. Do we know what player? Can you get me into one here?
Oppo 1.
Okay. And the first thing I actually want to talk to is what Robert was last speaking about. We was going through all the price points of the TVs, etc. I've seen a lot of things on the net, on forums. A lot of people are wondering, why do we put the 105 in here? Why is Sony's $25,000 product in here? We want to define this event right now, which we failed to do yesterday. The definition of this event is to determine the very best flat panel television on the market today. We never said it has to be under $10,000, under 50, under 5. So the price points of these things, we're not even considering them. We're evaluating the flagship products from these manufacturers and deciding what is worthy to be up on this wall. That's one thing. The other reason for very large screen sizes, of course, Joe Kane started talking about it. It's an issue we're all kind of grappling with, is Ultra HD or 4K resolution. If you're too far away from the screen, you're not going to be able to actually appreciate that additional pixel count. So that's another factor that was, considered in choosing them. So, do we have this MIDI coming up? What's going on?
MIDI should be coming up.
Okay.
HDMI wants to be.
So, over the years, I've broken this evaluation process into three main categories. A lot of you have been to these, so you know what they are. Number one, and in descending order of performance for displays, we start with contrast ratio. Contrast ratio has a couple elements to it. It's basically dynamic range in video. How dark can you go? How bright can you be? Other things, especially with some of these new technologies, actually affect perceived contrast ratio versus measured contrast ratio. We will talk about that. We'll demonstrate it. We'll show you both test material, always starting with test material, but following up with real program material, and we're going to try and guide you as to what to look for in these different categories. Now, with contrast ratio, for us, it's all pretty much going to be determined by black level, because in the night modes, which we will change all these TVs to after we're done looking at the day mode for a little while, we've set peak light output at 40 foot Lamberts. So the brightness of the displays are all exactly the same. So now it becomes, how good is the black level? That'll determine the contrast ratio. You have spreadsheets, all of you, that were given to you when we started, that actually lay out the contrast ratio measurements of each device. We measure contrast ratio, we call it sequential contrast ratio, with an ANSI 4x4 checkerboard pattern. The ANSI method is really entailed and takes lots of time. We don't have that kind of luxury, unfortunately, but we simply measure the white and the black squares and then divide the white into the black to get the number.
We measure the white and black squares on screen.
Yeah, on screen.
On screen.
With, oh, well, that's a good point. We should tell them what we're using, too. The equipment used, all of us own Klein K10As. They're really, really good colorimeters, but they're also capable of measuring very deep black level. Generators used were 4K generators. New piece by DVDO. It's called AV Labs TPG. And then, of course, test signals from a variety of different Blu-ray test discs. Joe Kane's HD Basics, Spears and Munsell, HQV, Silicon Optics for some of the processing tests that David's going to go through later. Some we made. And so the first category I'm going to lead off with is contrast ratio. The second category is overall color fidelity. That encompasses a number of different parameters: color decoding, primary and secondary color accuracy or color gamut accuracy, color gamut luminance accuracy, grayscale tracking, of course, and then I'll be handing that off to Dwayne. We will, of course, all be interacting with one another and speaking to different points as we see fit. And then Dwayne will pass that baton on to David McKenzie to do the processing and the scaling and the motion resolution section of the evaluation. So let's get started with contrast ratio. Everybody take a good look around. I've left the lights on purpose for the day mode. Take a few minutes to make some notes or whatever on which ones you think would. Oh, you don't know what TV's what? Okay, sure. Oh, this is not in day mode, is it?
Oh, sorry.
Up top.
Out of sight, out of mind.
What's that? So fine. So the set up on the top is last year's winner. It's the PN64F8500 plasma from Samsung. Going to the far left, Samsung's flagship consumer, as Mike Wood called it. This is a UN78 HU9000 edge-lit LED backlit LCD panel. This is Sony's XBR 79 X900B edge-lit LED LCD panel. Samsung's UN85 HU8550 direct array LED backlit LCD panel. Sony's XBR 85 X950B flagship direct full array backlit LED LCD panel. Samsung's flagship 105 S9 21:9 aspect ratio full array direct backlit LCD panel. Moving back to the other end of the room, got Samsung's KN55 S9C, C for curved, OLED panel.
55 EC 9300.
LG's
55 EC 9300.
OLED.
So well done. Let me know if you need weekend work.
So just a couple minutes to look at this material, and then we're going to dig into contrast ratio.
I want to say one thing also.
Please, go ahead.
Sorry. I want to say one comment that's for all three of us here that really needs to be known. We are objective evaluators here. We're not here to sell you anything. We're not doing any marketing. We're not doing anything but speaking the truth, the whole truth, and nothing but the truth about what we found in every single display, the good and the bad. Okay, we're not going to be picking on any manufacturer. We're not going to be, shining the light on any manufacturer. This is going to be an objective review, evaluation from all three of us. We have too much integrity, too much respect for the industry and ourselves, and we love and have a passion for this actual event that we're never going to jeopardize that for anything or anyone or any manufacturer. We just have to say that because a lot of individuals have been saying that it's kind of jaded. No, we're not jaded for anyone here. So I just want to make that clear for everyone.
I got a comment to that to add, too. Yeah, thank you, Dwayne. And finally, though, rather than looking at, oh, okay, well, I'm going to tell you that this certain display does something that is not perfect, I'm going to tell it to you, and I'm going to tell it to the manufacturer as an opportunity for improvement, because that's also part of what we do for a living, right? We pinpoint performance areas that can use improvement, and we hope that our clients do something with that information. So with that said, let's start with contrast ratio. One other thing that happened last night, I want to try and kind of manage a little bit, but and Mike touched on it. We have to get you up out of your seats pretty frequently because of the display technologies, especially LED. Off-angle viewing is an issue. If we're pointing out something that you need to be looking at, if you're off 20, 30, 40 degrees horizontally from that panel, you're not going to be able to see it properly. But so each time we have some test material or video playing and I want to get you guys and gals up, I'm going to give you 4 or 5 minutes to get up, walk around, take a good look at each panel, take a note if you're voting on an item. But we've got to kind of try to manage the time and the level of talking as well. So we'll shut the lights off for that. And then when we're ready to get you guys to sit back down, I'm going to have somebody bring the lights up so that we can just keep moving forward and focused on the evaluation.
And of course, so that you guys don't trip over anything when you're going back to your seats.
There you go. Okay, good. All right, so let's get started with contrast ratio. Hey, Robert, could you have somebody shut the lights down for us now? And the other issue is that light's going to be, yeah, thank you. All right. I just did. I'll do it again. You've got a series of stripes here. The reference for black in our system for video is 16, white 235. So what you're looking for is you want to see 17. You do not want to see 16. 16 is black. 17 is just above black.
One thing I'd like to add to that is that the display should come smoothly out of black. So in other words, we should have a deep black here, but we should be going from 17, 18, 19 in gradually lighter steps. We shouldn't suddenly be going from 17 to a much brighter tone. This display is getting it right. I'm just using this as an example.
Hey, David, I got something to say. Somebody pointed out that if you look at the Sony 950B in the right corner, you'll see that the luminance of these stripes is changing, and that is being caused by the local dimming. So
The algorithm's not stable.
there you go. And there's another test we're going to do a little bit later with an actual Blu-ray test, Blu-ray movie disc that will show the same kind of thing happening, but with real content.
Hey, Kevin,
Yeah.
can you mention that this Samsung, we're looking through the louvered filter, so if you stand right in front of the room,
Yeah, no, you actually want to stand back.
You want to stand in the back of the room
Yeah.
and judge the Samsung because.
Le- Larry has a great point. Dr. Weber's telling us the F8500 plasma that's up high on the wall, which is obviously not its ideal position, you should stand back further in the room to look at that because it has a louvered filter on it for ambient light rejection, which is keeping you from seeing this correctly. The other thing in this pattern and in the next pattern that I'll put up, which is a black field with a white border around it, that you can be looking for is what we call black uniformity. How uniform is the black in the image? That has a lot to do with the perceived contrast ratio that you'll see from a display. And generally speaking, edge-lit LEDs have poorer black uniformity than full array, direct array LED. All right. Hey, you know what, David? While they're all up, why don't you switch over to the USB? Let's put that black level, black field on. Don't go getting seated quite yet. We got a couple more things for you guys to see. This is one of the homemade test patterns that we came up with. It's a black field with a gray border around it. What's the luminance of the gray border, David? Roughly?
Around 20%.
Okay, and the reason that we did this is because we want to measure black, but on a lot of the LEDs, they cheat, and the LEDs shut off completely, you get nothing but zeros. So by putting this gray border around the black field, we're actually stimulating those LEDs slightly so that the panel doesn't go completely off.
This is a better indication of what you see on the black levels of LED LCD. Now, of course, this is the absolute worst, because with the local dimming, they will dim, of course, depending on the APL of the content, but this is the true what they're doing.
All right, I'll give you a couple more minutes on the black field, and then we're going to show you some Blu-ray movie content to illustrate some local dimming problems on certain displays, and it'll also be a very good demo for black uniformity. Okay, next up, we're going to put a chapter from Harry Potter and the Deathly Hallows Part 2 in a loop, and I want you to take a real close look at the pan down the hill. At the bottom on the hillside are a bunch of people with torches, and the torches are little teeny lights. I want you to get up again and look at this on everything very carefully. We have one panel that has some local dimming issues that, in fact, it has some of the best black level in the room, but with this particular material, the local dimming is
Tripping up.
It's blooming around the white parts of that picture and actually lowering your perceived contrast as a result. And that's the 950B Sony here in the right corner. This is also a good scene to look at for just the uniformity of black and the overall black level from a subjective perspective. And we're going to give you one more final black level test to look at. It comes from an older Blu-ray made by Pioneer called the Curo Test Disc. Okay. Hey, guys in the back, could somebody turn the light up for me real quick? All right. Conversation press again. All right, we're going to show one more thing in the contrast ratio category, just doesn't really relate it to contrast, but a little bit, I guess. David McKenzie.
Can we get your attention, please?
Hey, folks, one last thing in this category we want to show you. David McKenzie has made a test pattern that actually will allow us to count the local dimming zones, the LED zones on the. We did it on the full arrays, not the edge lit. It's a pretty neat thing. So we have some numbers for you on that. We promised you we'd give you some counts on LED zones. And you have that info on the sheet over there, I think, right?
We do.
So we apologize to the manufacturers up front, but it is our job to provide information like this that's useful, and this happens to be one of the things they don't like to talk about too much.
Right. We originally had this issue at HDTV Test where we would ask the manufacturers, well, how many zones are in this? And their PR people either didn't know or didn't want to tell us. So I said, okay, we'll find a way.
has 2 million zones.
Yes, it does.
Good answer.
One for each pixel, that's correct.
Well, so does the OLED.
Exactly.
That's what we need for LED, by the way.
Yeah.
It's just too expensive.
Cool. All right. So let me just repeat this so we don't go out. Yeah, so this is just a really simple, when we were originally reviewing these displays, it'd be better with the lights down if you want to, count along with me. But when we were originally reviewing these displays, we would often plug in our computers and move the mouse around in a black screen, and then of course we found out that was a really good way to just see how many zones there were in local dimming displays. This is just a Blu-ray disc of the same concept, so especially if you're off axis, you'll easily be able to see on any of the local dimming displays, you'll be able to see the individual zones light up. So, let me just skip forward a part. There's a whole bunch of different variations of the pattern on here. For example, if we're looking over here in 1 second, let's go for a slower version. No one can count that quickly. All right, audience participation, count with me. 1, 2, 3, 4, 5, 6, 7. And down the way. 3.
All right, so David, you want to tell us what your count was?
If we can see that's why we put the lights on before. All right, results are in. So for the Samsung Direct Array, 85HU, 8550, 8 zones only. That is in the vertical axis. Sony XBR85 X950B Direct Array LED. That's 17 horizontally and 9 vertically for total.
Can you turn up the lights so we can write these down?
Yeah,
Okay.
somebody turn the lights off. That's a good plan.
Okay, and
And
start
also,
over.
I think it's important to say that this information is very strictly confidential.
It was a moment ago.
The
Did you tell it got on the net? You mean?
yeah, the manufacturers do not release this
Wait.
information. It's a well-kept secret.
You mean the feed is still on?
That's right. And further, this was developed by a friend of mine, actually, with me. And let's see, is he here?
Apparently we're
David is here.
close, but no cigar. Apparently we miscounted in the Sonys. I don't think they're going to tell us the exact number, but it's
Actually lower.
okay. So the Sony has
Which Sony?
the X950 has less than the 153 we somehow came up with. Oh, okay. Look. So they didn't say less, or the number. Okay.
How many by how many?
They're telling us it's not 17 by
Just
now.
tell them what you counted.
We counted 153, but Sony are telling us that is not quite correct. Close, but no cigar, apparently.
What's the array? 17 by what?
By 9 is what we counted.
And why wouldn't it be 16 by 9, I wonder?
Maybe there's our clue. And the Samsung 105, we counted 230 zones.
How many by how many?
The 23 by 10. A little low, but close. Okay, so the pattern needs to be refined, is what we're being told.
We're working on this.
Yeah, next year we'll get it.
Tell them the name of this counter?
Well, we originally called it. I think it's funny too. We originally called it the zone detector. That's ZOHN, and Robert was so delighted I called it. But then when I put the disc together for the shootout, I called it FALD zone counter. So ZONE. So I apologize for that.
That's okay.
Next
Really
year,
developed
next
by
year,
Dr. David Schenck.
next year it'll be more accurate, and it will be called the zone detector again.
Yeah.
All right.
Cool.
I think it's time.
And I was with Toshiba last year. Yep. Let's do it.